Hello, scholars. Today I'm going to teach you how to select and run your correlational test in JASP, including assumptions. So let's say I want to know if and to what extent is there a statistically significant relationship between a person's skill and their aptitude. Okay, well, I already know that my data is continuous. Here's skill, here's aptitude. This is continuous. So I'm going to select a Pearson R. If it was ordinal, I might select a Spearman rank order. Okay. But in order to order my tests, I'm going to go to regression. And I'm going to select correlation under classical. And I am going to move my two paired numeric continuous variables over here under variables. And I'm going to select a Pearson R test. If I wanted to run a different test, they're right there. Okay. I'm going to want to display pairwise. And I'm going to want to check my hypotheses. Most of the time, you're going to be doing a two-tailed test, so you'll just select correlated. But if I just wanted to look one direction, positive or negative, increase or decrease, there's the other two alternatives. And I'm going to select a scatter plot because I know that there is an assumption of linearity with a Pearson R. Here's where I'm going to order my assumption checks. Now, if I had more than two variables, I'd select multivariate normality, but I'm just going to select pairwise because I just have two variables. Okay, and you can see the results of everything. So let's look at this just for starters. I'd say the assumption of normality or linearity, I'm sorry, is met. Here's my scatter plot. It sort of looks like it starts to form a line. And then I can look at my correlation up here. Remember, my null hypothesis is that there's not a relationship. So my alpha is automatically set to 0.05. Is there a relationship between skill and aptitude? And look, my p-value is less than 0.001. That is a significance. And my Pearson R number here is 0.429, which is a medium moderate strength. And it's a positive number. So I have a positive moderate line. Now, what about normality? Is my data normally distributed? Remember, the null hypothesis for a normality test, the null is that it's normal. So if it's significant, it's not normal. Well, my p-value here is 0.847. That is greater than my alpha of 0.05. It is not significant, so my data is normally distributed. Okay. Now, we also inspect a box plot for significant outliers using a Pearson R. Let me show you how to do that again, because we have to do a little bit more to determine if the outliers, if there are any, are significant. So now I'm going to go back to descriptives, and I'm going to select descriptive statistics. And again, I have to move my variables back to variables, and I'm going to go to customizable plots, and I'm going to select box plot element, and label outliers. And then if I have outliers, I have to calculate if my outlier is significant. A significant outlier is greater than 1.5 steps from the edge of the box. So let's look at that. Okay, so let's look at mine. Well, let's look at skill because I've got an upper outlier and a lower outlier. So case number 13 and case number 12 are both outliers under skill. See that there? So I'm going to have to calculate if they're greater than 1.5 steps from the edge, that's an edge, and that's an edge, from the box plot. Okay, so now I'm going to go back to statistics here. And first I want to select quartiles. I don't need all this extra stuff right now. And I want interquartile range. And then up here, it's going to give me those numbers when it's done calculating. Okay, so we can see that right here. Now, to compute that, is it greater than 1.5 steps from the edge of the box? I have to compute the score that's 1.5 steps below and 1.5 steps above. Okay, so I've showed you what to select. Now I'm going to show you how to do it. All right. So for the lower threshold, it's quartile 1 minus, and in parentheses, 1.5 steps times the interquartile range. For the upper, it's quartile 3 plus the product of 1.5 times interquartile range. So I worked through my example. All right, so for the lower threshold, okay, quartile 1, and I circled it where it shows 25th percentile for skill. My number was 3.188. And my interquartile range, which I use in both formulas, is 0.690. And I circled that on your output here so you can see where it is. So first we do what's in parentheses. 1.5 times 0.690 is 1.035. Now I'm going to take my first quartile score, 3.188, and I'm going to subtract that amount. So the lower score, if it's less than 2.153, it's a significant outlier. So we'll go back and look at that in a minute. And for the upper threshold, it's the same thing, but I'm adding them, right? So my upper quartile, third quartile, 75th percentile, was 3.877. So 1.5 times 0.690, my interquartile range, equals, again, 1.035, which we determined over here. And now we're going to add the third quartile to that. 3.877 plus 1.035 is 4.912. So for my upper outlier to be significant, greater than 1.5 steps from the edge of the box, any score would need to be above this on the upper end, because you can have more than one outlier on either side. So to be significant, now we take these numbers and we go back and we look at our data file and we find those cases, which I did for you. Here's case number 12, which was too high, and case number 13, which was too low. And then we find the score. Here's the skill column. So we said for it to be a significant outlier, the score would have to be greater than 4.912. 2. Well, my score here is 5.013 if I round it up. That's greater than. This is a significant outlier. It's greater than 1.5 steps from the edge of the box on the top. On the bottom, we said the number would have to be below 2.153. If it's lower than that, it's significant. Well, this number is 2.123. That is below the minimum threshold that we calculated. So that too is a significant outlier. Now, how do I know if these outliers are affecting my data? Well, that's easy. I can go look at my normality test, which I've already conducted. We have already determined that my data was normally distributed. Okay? It's normal because P is greater than 0.05. Now, let's say P was violated. I could remove those two cases from my analysis and check normality again. And if normality is not violated, I can make my decisions. However, I maintain that it is unethical to remove data points if they're accurate because they're inconvenient. You'd have to have a good reason to remove them. So I would leave those data points and I would select a different test. In this case, I would select a Spearman row, a rank order test, because normality would have been violated. I would select that and I would keep all of my data. Okay, so in your homework, when you discuss it, you need to make recommendations based on the assumptions. There's always choices to be made. This is why we defend our dissertation. All right. Well, I had 2 significant outliers, but it did not affect normality. So I proceeded with my test. I had 2 significant outliers and normality was affected. So I switched tests and used a Spearman rank order instead. Okay. I am not going to require you to retest in any of my classes by removing outliers. Again, that goes to ethics. A scientist is transparent with their data, and you don't remove something just because it's inconvenient. Okay? If you have any questions, please reach out to me. Thank you.